Okay. Okay. Welcome to the second session of modeling. We start with the first speaker, Maria Carla Ciacchella. We go back to the modeling, mathematical modeling on what we call the future cultural heritage. This means the buildings made of concrete. Please. Thank you.
Okay. Good morning to everyone. It's a pleasure for me to be here, so I really want to thank Gabriella for the opportunity. I'm Maria Carla Ciacchella. I'm a conservation scientist, and I work at the CISTEC, the research center in science and technology for the conservation of historical and architectural heritage. Today I will present you the latest works, and the forthcoming developments of the research group which I'm a member, in particular in relation to a specific building material, which is concrete, and mathematical simulation on this material. Okay. In the field of the conservation of cultural heritage, we mainly refer, when we talk about building material, we mainly refer to natural stone, bricks, plasters, iron, and mortars. And this is, of course, due to chronological reason, which is the widespread and extensive use since ancient times. There are many studies on characterization, provenance, and degradation of these type of materials, and fortunately, there is more and more multidisciplinary approaches with the integration of mathematical tools, which are very useful to support our archaeometrical research. But there is one building material that makes up an ever-growing portion of our cultural heritage, which is concrete, and it must be considered. Okay. So concrete is the most significant material in the 20th century because it was, of course, there was a belief of its eternal property and eternal durability. So here we can see some example: Casa Kaufmann by Wright, Le Corbusier, Zadi Maxi, and the Italian by Santa Calatrava and Federica. I choose these four structures because they share some peculiarities which are problems from a conservative point of view. First of all, they are all structured with an exposed concrete, so there is no plaster to protect these structures from the environment. And the other characteristic is the particular shapes. Quite often, these shapes make the edges near to the surface, and this is, of course, another conservative problem. We have, of course, to recognize concrete as a cultural heritage materials, and we have to improve the preventive diagnostic of this type of buildings. A brief introduction about concrete. Of course, we generally speak about reinforced concrete for the presence of steels, which are responsible of the tensile strength, and concrete a mixture of water additives, aggregates, and binder, of course. Since concrete is not eternal, it suffers many degradation processes. First of all, the corrosion of the steel bars, which can be a phenomenon that could be triggered by the penetration of chlorides, and the carbonation, the sulfate attack to the cement tissues matrix, but also the mechanical degradation caused by freeze-thaw cycles, especially in high latitudes. And another phenomenon that I will better explain, which is the salt crystallization in the porous medium, generally considered only for natural stones. Okay, here you can see some examples I faced in the last words. Still corrosion. Corrosion, of course, occurs when the pH is not yet at 12, so the high alkalinity is lost. And as a consequence, the condition of passivity for the bars are not met. Another example are black crust, and this is very common in our city, close to, of course, the pollution. The action of sulfatation by the water rain can cause the precipitation of gypsum. This is not only a static problem, because when the crust grows, the thermal mechanical behavior of the crust is different from the substrate, and this can cause detachments, which are more in general a consequence of mechanical stress on the structure, and the structure is not able to absorb them, and it can cause detachments. I want to show you our workflow when we face a conservative problem. So first of all, we have to observe the structure in its context. So from a macro to a micro scale, trying to have an overall view of the structure. Then we pass to identification of the distribution of this phenomena. And then only if the in situ observation suggests further investigation, we will sample. After the sample, of course, we pass to laboratory analysis. Here I try to simplify it in the three main groups. First of all, the imaging techniques. Here you can see example of microscopic picture, mapping by using microscopy electron. And the imaging techniques, we usually use them for the analysis of morphological and microstructural properties. The second group are the chemical investigation. Here you can see, for example, of XRD patterns, so X-ray diffraction. The second one is a thermal analysis, and the last one is a micro-Raman. We use them for the characterization, to get composition information, and for identify the various crystalline phases and the symmetric of reaction. Of course, we also conduct physical and mechanical tests to know the performance of the concrete in this case. Our work can be emphasized and with the mathematical model, and this is a very powerful simulation. Maurizio Cesari, I don't know. Maurizio Cesari would, of course, explain all the mathematical parameters and the results from, of course, a mathematical point of view tomorrow. What I would like from my point of view is to explain to you what are the advantages of such a model from an archaeometric point of view. First of all, the description of a very complex phenomena. We have the possibility to consider at the same time different factors, such as different materials or different expositions. The possibility to identify long time effect of carbonation of concrete, because differently from the other material we generally deal with, we don't really know the long-term behavior of structure made of concrete. And this is the best possibility to solve the time problem. This model also allows for the prediction of the progress of the events and to correct some experimental data, especially when they are very difficult to calculate. This model also allows the resolution and open debate that regards the effects of carbonation on the microstructure, in particular on the porosity. And since it is a very well-constructed model and all the variables are separated and all the chemical steps are separated, we can use it as a structure for further development of new models. And what about new perspective? In a few months, I will begin my PhD, and it will be devoted to the control of self-crystallization using an inhibitor in concrete. This is the main problem I have to face, which is the self-crystallization in porous material. Basically, as soon as a solution which contains saline ions, such as chlorides, sulfates, nitrates, or carbonates, in particular chlorides, which becomes both from sea-marine water, so it's a problem for the seaside country, but also from the de-icing salts, so it's a problem also for the high latitudes countries. When the solution reaches the condition for the evaporation, the salts precipitate. This precipitation could induce a stress which is higher than the tensile strength of the material, and it compromises the integrity of the structure. It is very difficult to work on the environmental control, especially for outdoor structures. And the classical methods used, for example, desalination or washes, are sometimes not too efficient or too expensive. A great attention in the last years has been paid to the inhibitors, the organic or inorganic inhibitors. In particular, a very interesting study Professor Sabaraki introduced and explained yesterday is about the use of phosphosiderate as an inhibitor for the crystallization in porous materials such as stone, bricks, and mortars. And they also tested the effectiveness of this inhibitor in collaboration with the mathematics of the CNR. And it is a very powerful instrument before the commercialization of this type of product. This is what I hope I'm going to do. Phosphosiderate as an inhibitor, so again, a biomass product, functionalized molecules from the polycarboxylate. We will try to work in agreement with the green chemistry, so trying to avoid the waste using the ionic liquid solvents and minimizing the energy. We want to increase the system of variables, trying to analyze different substrates on different cell solution in binary and ternary mixture in different microclimatic conditions. And of course, we want to shift the focus from let's say, the classical materials of cultural heritage to concrete. There is a problem which is related to the application, because the other inhibitors are absorbed by the material, and this is not possible for the microstructure of concrete. So we want to achieve a product which can be inserted directly in the premixing, and this is of course a declared preventive character, different from the intervention. This is the workflow we are going to use. So first of all, laboratory analysis, the production and characterization and the salt treatment of the specimens, the synthesis of the inhibitor, the evaluation of the effectiveness And I really would like to, again, try to construct a new mathematical model for the firmness of these indicators, the data rationalization, because of course we expect a huge number of data that must be managed, and a pilot application, and I'm proud of it. Because we have agreements for the Grande Decreto by Alberto Burri Gibellina. For those who don't know, Gibellina was in Sicily. It was completely destroyed during the 1968 earthquake in Valle del Belice. And Alberto Burri decided to incorporate all the rubbles, the ruins, the remains of the ancient city, and this is considered the greatest landscape art in the world. And we want to use our product on the Grande Decreto. We have some contacts and first intention with the local institution, but we also want to activate a microclimatic campaign. And what I would like to arrive is the construction of a mathematical model knowing both the environmental condition and the characteristic of the concrete we are dealing with. So this is what I'm going to do, and I hope in the next MAC to present you some results. So thank you for your attention.
Very much. I think that you have a good ground for your PhD. There is a question, comment, please.
Thank you for your talk. It's just an understanding question. So you want to study carbonation, right?
Yeah, we study carbonation.
That's a big plan. But in fact, you want to study crystal inhibitors for salt crystallization.
Yeah.
So your reason is carbonation makes pores bigger and chloride sulfates enter quicker in the materials, right? Is this what you say?
I'm not understanding.
So what is the connection between carbonation and salt crystallization? They appear to be two different things.
Yeah, two different things, but I want to show you the workflow that conducted me to
the salt crystallization.
And we had constructed a very powerful model, but I want, I'm not a mathematical, so the mathematical implication would be described tomorrow by Maurizio. A different phenomenon, but of course, we have to consider in the totality of the phenomenon, but they are different, of course.
No, I understand. So you may want later on to have a salt crystallization module on the carbonation model.
Yeah.
Okay. Thank you very much.
Any other questions?
I don't know if you know about the history of concrete research, but for your experience, are there differences in terms of fragility, degradation between the concrete, the beton brew of the 2030s during the age of Le Corbusier and the current concrete used in our
yes, of course they are, and in particular, I will talk for my experience. I had the opportunity to study a fascist structure made up by Joe Ponti, and we had archaeological information, let's say literature information about the composition of the concrete. And we studied the constructive technique and the materials, and we realized that it was totally different. So in the autarkic period, they declare the use of some aggregates binders, and it was not absolutely in this way in the in the structure realized. So I think we are going, of course, to a better formulation of concrete with respect to what we were used to.
Okay.
Thanks for the question. There are other questions, comments? from the online participants? No? If not, we thank you again.
Thank you.
And now we go to the next speaker, Nicola Masini, senior researcher of CNR. And I think we are going to talk about data.
Okay, thank you very much. Yes.
So there are people that want to listen to the talk online.
Yes.
Okay.
Can I start? Yes. Well, I thank Michela Spagnolo for inviting me to attend this conference, and this is my.
Because we are online
Yes. Okay.
no. Okay.
Yes. Well, I'm just thanking who invited me.
Okay.
We are online.
Okay, can I start? And I'm very happy to stay here because it is my first face-to-face conference after the COVID. So I'm particularly happy to participate to this interesting workshop. Focus on remote sensing and spatial data science. I work in a multidisciplinary institute, Institute of Heritage Science, and I work in Potenza, where we in particular develop methodologies based on Earth observation for cultural heritage, including archaeology, including also conservation of architectural heritage. And in my presentation, I will show a brief overview of automatic or semi-automatic approach for the extraction of feature of cultural interest. Let me start with this consideration about cultural heritage, which is usually considered only the legacy of tangible and intangible heritage assets to be maintained and transmitted to future generation, as we usually say. But cultural heritage is also a field, a domain of study and research, where multidisciplinary approach skills are combined, contaminate, thus stimulating the development of new methods that in some cases could be reapplied in other fields. So what we are living is that the past model paradigm is changing. In the past, some technologies, methodologies developed in other fields were adapted, motivated, adapted for cultural heritage. Yes, I can push if you want. So I say this. This is the reason is due to the heterogeneity of data to be analyzed for a multidisciplinary work study. We use historical sources, but also a number of data provided by different imaging systems. Heterogeneity of the phenomena to be observed from the chemical degradation, as we saw before, structural risks, and objective from safeguarding to conservation. And in this context, remote sensing, one of the most, I push, promising tools for cultural heritage, which allow us to have a multi-scale opportunity to analyze cultural object in a larger context is remote sensing. Remote sensing is a technique, is a non-invasive technique, which allows us to acquire data of a number of biophysical parameters without any contact with the object, length of phase, phenomenon to be investigated. And in some cases, these allow to understand, to detect, for example, in archaeology, some proxy indicator of archaeological interest. And just in this field, the large available amount, the availability of a large amount of data, I refer to space satellite data, for example, but also data of diverse platform, aerial, terrestrial, which today are available at different scale and different resolution, and the variety of information that can be obtained make it necessary to use, to develop, and to use automatic and semi-automatic procedure to redact the data, but also for extracting useful information about a particular feature or pattern of a cultural interest. Speaking about satellite technology, I just show the constellation of Copernicus, which is a family of mission called Sentinels, which carry a range on board, a range of sensor, from radar to multispectral imaging sensor instrument for a number of applications. Ocean services, some of these analysis related to the presence of a proxy indicator of archaeological technology could be used also for archaeological application in archaeology and cultural heritage. So big Earth observation data emerged in the past few years as a powerful tool which serve a number of applications, including environmental studies, climate change studies, of course also cultural heritage, from the archaeological research to documentation and monitoring and preservation of cultural heritage. In my presentation, I will rapidly show an overview of some approach developed by my laboratory, just to show how this integration of remote sensing and spatial data science could be used for studies in archaeological landscape, for the monitoring, observation of archaeological looting. Archaeological looting is the clandestine excavation, for extracting archaeological feature. So, with in the context of a preventive archaeology project, and finally to extract patterns of degradation pathologies of architectural and artistic heritage. I start with the archaeological application, that is the application that consists in detecting remains of archaeological interest. To understand how it is possible, it is important to analyze, to observe the entire degradation process of a building, of monuments that over time after a long process of deposition and erosion, are part of the soil. And so a physical interaction between the soil and the buried remains produce a change in moisture content, change in the vegetation growth, soil nutrients, which are visible from above as marks, the so-called crop marks, dump marks, and soil marks. If we use multispectral imagery, we can analyze the optimal spectral interval, spectral band or window to use to emphasize the difference between these marks and its surrounding. Here you can see how the vegetation can change in presence of buried structure, and so these different state of healthy vegetation are reflect in a different way depending on the spectral band. So analyzing using the spectral signature, we can improve the detection of archaeological feature. This archaeological feature, I mean in particular dump marks, crop marks, change over time, change from a season to another season. Here you can see a multi-temporal series related to Machu Picchu, and you can see how these anomaly, these difference in vegetation growth change from spring to autumn to summer. So now today we have some free of charge satellite imagery that we can use exploiting the information content of a huge amount of these data, and using also in this case Google Earth engine that combines a catalog, a multi-petabyte catalog of satellite imagery and geospatial datasets. It is possible to process this huge amount of satellite data in order to enhance these marks that generally are variation in humidity, variation of growth vegetation, which could be related to the presence of buried archaeological structure. And this slide refers to an application on Appian Way. We analyzed two subsection of Appian Way. Of course, this study is a study in the context of multidisciplinary research, and using a buffer of 8 kilometers, two classes were identified on the basis of the available archaeological data record. The class where the area of archaeological interest are expected, on area where the archaeological interest, the Appian Way, is not expected. So using the spectral signature or simple analysis from mean to standard deviation, using Google Earth Engine, these two classes were calculated over the entire multi-temporal data set, enabling the identification of the spectral bands with significant spectral distance, but also to select the best image as input for further analysis, statistical analysis, from a principal component analysis to cluster analysis, which in particular we use. That is cluster analysis, particular local indices of spatial autocorrelation is used to enhance the textural characteristic in order to capture the presence of particular spatial patterns with possible potential archaeological interest. Particular, the Gare index help us to identify ages and areas characterized by high variability, which could be related to the typical, the famous archaeological anomaly. Okay. So just to show some results, it is the results of considering processing the entire data set from 2007 to 2020. It is a fast color of 3 bands, including near, red, and green. The other approach is to analyze, to extract the best satellite imagery to analyze, exploiting the single bands, but also to use other data processing algorithm from the simple spectral indices to some cluster analysis, as you can see, where this elaboration emphasize anomalies of archaeological interest. This approach of based on cluster analysis and unsupervised classification and segmentation is used also for example for other land surface, including the desert area, as in the case of this application. But in this case, the task was to identify area damaged by clandestine grave robbers. This is an application in Syria, Dura Europos, where we were involved in the monitoring, observing the phenomenon of looting. And well, remote sensing in this case, it was the only way to do this because of the impossibility to work in Syria. But what I want to emphasize is that in this with this approach, it is possible to extract feature related to the presence of these pits, this looting hole. Of course, with a percentage of errors or false alarm. The same more or less approach could be used also for extracting a feature archaeological interest, starting from a LiDAR-based survey. LiDAR is a technology which allows to measure to obtain point clouds and obtain a very high resolution digital model, which can be enhanced using some particular visualization techniques. And well, applying the same approach, Gary, in this case, Gary is a cluster analysis. For sake of brevity, I'll not describe, but if you want, we can deepen this. ISO data, it is one of the most common unsupervised classification, and finally segmentation, setting the parameters in appropriate way. And so this is an application of a medieval village in Kassel, observed, known by means historical iconographic sources. And so the approach was to enhance the digital model with these visualization techniques, which was the base for first a qualitative visual interpretation of archaeological feature, and then we try to extract in an automatic way the feature, and we compare them with the result of the archaeologists, which who interpreted the LiDAR-based derivative models. And so this was the result of this automatic extraction, with some good results for some particular feature, city walls, the castle, less higher error, and false alarm for other smaller feature. Anyway, the result was validated with the C2 field survey, and so this is more or less the comparison between the qualitative, the visual inspection of the archaeologist, of the expert archaeologist, and the results of the automatic procedure. You can see just to facilitate the comparison, the overlay of the feature automatically extracted, overlaid on the map, obtained by means the archaeological traditional interpretation. I conclude with this other application. Well, we change the scale of the object of the heritage object. It refers to frescoes in Pompeii in the Regio 8. Well, in this case, we try to develop a method for extracting in automatic and semi-automatic way patterns referable to some degradation pathologies, the degradation pathology which typically affect a wall painting, using a data set composed of RGB imagery. It's an ortho RGB, a digital relief model obtained by photogrammetrical methods using particular structure for motion, and multi-temporal infrared thermography, and georadar acquired georadar using a high-frequency antenna. So, first of all, we in the same case of the archaeology, the expert analyze the degradation pathologies, and in order to obtain the map of a number of the decay pathologies, from detachment to swelling, fracturing, and so on. The methods used were the use of HSV. So we transform RGB in HSV because it is the better representation for the image classification, because the RGB usually have has a higher correlation between the free bands. So we transform the RGB in HSV. We use also the digital, the geomorphometry to analyze the 3D digital model, cluster analysis already showed, and finally the SOM, self-organizing maps, which is a neural network architecture which reduced the n-dimensionality into dimensional lattice, and so through a learning algorithm without supervision, we try to use for the extraction of the patterns. The results were the following. Transforming the RGB in HSV composition, we identify some comparing, of course, with the RGB imagery, we extract, for example, the salts over the painting from the V component. Whereas V component. Yes, V component. The same V component, the same V raster, analyzed with the cluster analysis, allowed us to identify, to map a phenomenon of decoloration using, in particular, hotspot analysis. And finally, the H component of this composition was useful to highlight areas characterized by local detachment of pigments. As regards the DSM, which was basic methods taken from the geomorphometry, it was possible to identify. We have to say that the geomorphometry, the data were classified in a number of quantiles, and so it was possible to extract swelling, detachment, legs, in particular. 3 different depths were detected, more or less corresponding to the 3 layers of a fresco. And finally, the SOM allow us to identify, to highlight, and extract with higher precision the efflorescence patterns, efflorescence phenomenon. And finally, the GPR. GPR was very useful. GPR is a geophysical methods that if used with high frequency antenna, we mean 2 gigahertz, from 2 gigahertz up to 3-4 gigahertz. It is capable to to explore small depths of mortar, for example, with higher precision. So combining GPR and hotspot analysis, it was possible to identify for diverse depths different decay pathology, different to analyze, to characterize the state of adherence of the mortar, of the fresco on the masonry structure. It was the results, the comparison between the qualitative visual mapping with automatic based mapping. Just to conclude, heritage today is a multidisciplinary area that generates novel and ever more challenging methodological approach. And remote sensing enables effective application with, as I showed, with a multi-scale application with a different resolution from landscape archaeology to sensing artifacts. And the heterogeneity of information make necessary to develop ad hoc procedure for extracting automatic way feature and patterns of cultural interest. So the application here showed, and as well as scientific literature, show positive results. Also in the perspective to use these in operational scenarios. In the future, we are developing a UAS drone-based platform with different sensor from hyperspectral, multispectral, LiDAR, georadar, magnetic, in order to develop new methods for the processing, for the extraction of a feature from heterogeneous data from very high resolution imagery taken from drone. Thank you very much. Maybe I was language. Okay.
Actually, I have one first question.
Yes.
For curiosity. With this technique, it will be possible also to find out the composition of the monuments or the physical or chemical composition of the monument.
Well, this kind of you refer the drone, yes. What we are doing, not it is possible to have large imagery. For example, if we use hyperspectral imagery from drone, it is theoretically possible to extract different reflectance value referable to the different material which compose, for example, an architectural surface that we try to do in the future. With the same hyperspectral imagery, but from aerial platform or from satellite platform. It is something that I did in the past. It is possible to detect mineralogical components of the soil, of rock elements. That is an application for the mine activity, but it's also an application for archaeology. For example, for those study on ancient mines, also for the study useful to identify, for example, the obsidian, that is a particular important material for archaeological study, and so to analyze the cultural material of a civilization.
And the second question.
Yes.
You mentioned the first example. You mentioned the Gary.
Gary, yes.
You used the cluster analysis.
Yes.
My question is, how do you use the cluster analysis? What are your input data? Are the color of the pixel?
Yes.
Which kind of distances do you use?
Well, it's the color distance. The cluster analysis is used to produce the base map for a further classification, and after segmentation enable us to extract the feature of our interest. Of course, the procedure is ad hoc for the task. If we analyze the small bits of the bits of the grave robber, we set in appropriate way. For example, the parameters for the cluster analysis, in particular Gary, is used, and also it is important to set in appropriate way the classification and the segmentation of population of the pixel and the other parameters.
There are any.
Well, thank you for the overview. Okay, to understand it, for a second example, you have some regions, some pixels with a lot of information, thermography, yes, and in the color space. So, and then in order to classify, what do you do? What is the next step? I mean, possible to use a single, for example, in color space, perform some cluster analysis, or build a very big vector in a high-dimensional space. A vector contain thermography, color space, something like that, and then try to.
Now we use the single data. So for for each data set, each type of data, we use an approach. In some cases, the same approach was used for two data, but not together.
Mm-hmm.
Alone.
Okay. So you have not a big dimensional space and then many feature.
We try to do this. For example, we try to the difficulty is how normalize, for example, a time slice of GPR and infrared thermometry. This is the problem. Well, maybe it's possible. There are some difficulties in trying to put everything in one vector. In the future, we want to we'll try to do this.
Okay, thank you.
Another question?
So,
I have a quick concerning the validation of segmentation and of the classification. Do you have any way to validate the correctness of the results of the segmentation? And do you keep this? Because there is a lot of data and of value. And having also the validation of the results.
yes. Alors, you refer to the archaeological application.
Yes.
Well, about the methods for extracting looking feature in Syria, we validated by independent data, aerial imagery, and also OLF. Finally, so it's not very the typical validation that you can do because in Syria it was not possible. Whereas I didn't show in Peru, we validated the same algorithm because in Peru we have emission and we validated with the field survey, drone. In some cases also we conducted the GPR prospection that in some cases put in evidence that the hole caused created by the tombaroli, the grave robbers, concerned still the treasure, the archaeological treasure. So, well, we did this validation from drone to GPR, but in the case of Syria, it was not possible. Whereas in the other application, yes, we conducted a typical archaeological validation. So each microlith of potential archaeological interest was analyzed on site to verify if it was something related to archaeological feature or something related to a natural geomorphological feature, because well, the possibility to do error is very high. This kind of techniques that we use.
Okay. There are other questions, comments, online people, the chat. There are questions, no? Okay, so we thank again. Now we go back to the point of view of our scholar with the next speaker, Rita Reale from the Accademia Aldo Galli.
Sì, metti come PowerPoint. Di prova? No, il relatore però. Se c'è sottotitoli. Aspetta. Non so come lo fa. Non con i sottotitoli non. Okay, good morning, everybody. I'm a restorer and also a scientific conservator. On Zoom, we don't see the presentation. No. No. Reale. Okay, again. Good morning. I'm a restorer and also a scientific conservator. And we have seen that in recent years, many mathematical models have been developed as a support in the field of diagnostic and conservation of cultural heritage to understand, for example, the structures of different material or the origin and evolution of the degradation form. In this meeting, I would like to present my personal experience on how much mathematics is present in my work when I operate on different materials. A work that, as a title suggests, can involve paintings, stone, metals, or wood related to the daily operation of restoration and to the form of degradation cultured. And even though the restorer uses only a little bit of mathematics, this one is often replaced by a dedicated computational software. Let's go to see this application. Here we have, for example, first is the problem of handling in artworks. Second, how to find the area of a regular and irregular shape. Third, how to find the right tension for canvas paintings. And fourth, how to prepare a cleaning solution. I worked for 5 years at the Stone and Cast laboratory of the Vatican Museum, where I was able to observe an important operation related to the handling of artworks. Handling is a very delicate operation that requires special equipment and precaution to safeguard the well-being of the artifact. In fact, museum conservators always follow the rules given on loan for exhibition, usually packs the item going out on loan and will require that all items be repacked for return in the same manner as when they were sent to the borrowing institution. The conservator's presence will be always required during the transport, unpacking, installation, the installation, and repacking of the borrowing institution. That's because damage during handling are very commonly, and they can be due to an example to underestimate the weight of an artifact, not seeking assistance with lifting and moving, not using proper equipment and materials, and incorrectly manipulation, and so on. Know the size, the weight, and the shapes of an artifact allow us to choose the right kind of containers that contribute a safe handling in museum or to an object safe travel. So we know that the weight to know the weight of a stone object, we need to multiply its volume by the specific weight of the material. If we have an object with a standard geometric shape, we can calculate its volume by measuring its dimension and using the relevant mathematical formula. If we have an irregular object and we cannot use the Archimedes principle, we can measure regular parts of the stone and then add them together. Finally, we go to multiply the volume obtained by the specific weight of the material. In this case, how to find the area of a regular and irregular shape? In the specification of the contract for restoration project, the restorer is asked to define the cost of each restoration operation. To know the areas of a regular and irregular shapes, it is important to calculate the extension of degradation forms and the cost of the intervention to be carried out. In example, how much costs a cleaning or grouting intervention. Finding the area of a regular shape is very simple. Just use the formula that we all know. More complicated is calculating the area of a regular shape. How, in the case of volumetric shape, to find the area of a regular shape, we can divide these shapes into regular shapes such as triangles, rectangles, squares, etc. Find their area and add them up to get the area of a regular shape. If all of this is complicated, then we can get help from technology. To make our work easy, a lot of software has been developed, such an example, AutoCAD or Giotto 4+. If I work on point and canes, in some cases I need to reinforce the canvas or the stretcher or both. The stretcher and the tension of the canvas are two important elements for the preservation of the work. The original stretcher can be recovered or adapted to preserve any marks, future or evidence of the artwork passage through time. The simplest traditional stretcher is made of a wooden perimeter onto which the dating margin of the painting are fixed with nails, staples, strings, or glue. This direct and unbuffered bond between the painting and the stretcher exposes both elements to the forces from dimensional change related to the environmental condition. Different types of expandable stretcher make it possible to increase dimension through expansion. Measuring the elastic constant of the springs used with this kind of stretcher allows to calculate the value of the tension acting on the painting through the ratio that exists between force and elongation in the spring, F equal K delta L. A correct approach to determine the ideal elastic tension for a painting would be that obtaining a balance of the force expressed within the painting with springs that are able to produce an equivalent response to maintain a constant stress value. It is now possible to measure with a tensiometer the value of tension chosen for a painting and monitoring the results over time. In modern conservation, there was a recent reevaluation of what we are doing when we clean a work on art with solvent. New product and application technique have been developed and are now being used. Chemicals basis concept as acidity, alkalinity, solvent strength, and its interaction with materials can be used as a tool to help solve some of the waxing problems facing the conservators. We all have certain notion about solvent strength. Acetone is a strong but rapidly evaporating solvent. Water is weak and not really a solvent at all. Petroleum, benzene, naphtha, etc. are weak or very mild solvent. This knowledge allows us to refine the methods for preparing new cleaning product. Solvent and reagent, liquid form, in gel or emulsion form can be applied to various types of surface, paintings, marbles, metals, wood, and so on. But first of all, it is important to be familiar with the concept of proportion, percentage, and molarity to correctly prepare a solution. Also, in this case, some free software can help us for the calculation of the right amount of reagent. When choosing solvents, it is important to consider not only toxicity, but also volatility, retention, chemical stability, and other parameters like dispersion forces, polar and hydrogen forces. By mixing multiple solvents, we can achieve solution with a wider range of action using low toxicity solvents. We use a triangular diagram that contains the three coordinates that describe the solvent power, Fd, Fp, and Fh. One multiplies the parameter of each component by its concentration in the mixture and sums up the result. For maximum precision, molar percentage should be used, but volume concentration or weight concentration can be used instead. As an example, we can see in the table the parameters of different mixtures. A mixture can thus be located in the triangular diagram, and its behavior to a solid, whose solubility area is low, can be evaluated. To obtain a more accurate result, especially for three-component mixture, the use of a computer program is better than a visual shot. Different software can be used, Triansolve, Resolve, and Solvent Solver. Using this application, it's easy to find solvent mixtures that are more effective in solving a cleaning problem. Let's change the point of view now. What does a scientific conservator see? What are the decay phenomena hiding? Here we will examine three case studies that I came across during my work as a restorer, but analyzed with the eye of the scientific conservator, which are the Liesegang rings that form installed materials and which were the subject of my doctoral thesis and the object for the development of a mathematical model, the sectarian concretion, and the rhomboidal structure. Certainly more intriguing phenomena from a mathematical point of view than the experience of the restorer. They are phenomena that evolve from degradation of the material, often due to the synergic action of several factors, such as the presence of iron in the stone or wood matrix. But let's see exactly what this phenomena consists of and if they can explain it mathematically in order to understand and make prediction about the chemical damage of porous material and to give some help to the restorer. The first case study regards the Roman and Renaissance marble and the Liesegang phenomenon. In this case, the conservative problem is represented by the iron stain, that often we encounter on carbonatic stone. In fact, among the numerous conservative issues regarding stone artifacts, the presence of stains caused by metallic compound, in particular iron one, results to be one of the deeply felt problems, both from the aesthetic aspect and the chemical physical damage of the substrate. Iron, in fact, tends to oxidize rapidly, giving rise to colloidal hydrate oxide that, in contact with porous material, such as carbonatic stones, may diffuse from their source, as an example, iron linchpin, to the near stone mass, often with particular shapes, such as Liesegang ring. Liesegang ring represents a phenomenon on periodic precipitation observed both in simulated chemical system constituted by ions scattered in a colloidal medium and gel state and in natural systems, such as, in example, sedimentary rocks. Such phenomenon causes the formation of colored rings bands, more or less regular. An interdisciplinary study, both experimental and numerical, was performed here, where I was responsible for the experimentation of porous host materials. The first on a petri dish filled with colloidal agar gel solution and sodium hydroxide, while a second experiment was performed using ledge stone as the host materials. Both materials were placed in contact with an iron source to produce the ring. To describe the process of precipitation of iron in ledge stones, we propose a mathematical model that is a modification of Keller-Rubinov model, where the precipitation function is replaced by a smooth function to avoid the instability of the model. In such a way, we were able to develop a simulation algorithm capturing the main feature of phenomenon of Liesegang formation in the stone. The shape and intensity of rings depends on the nearness to the iron source, as shown in laboratory experiment, where the presence, shape, and position of the rings are highly influenced by the physical contact between the stone and the iron nail. In the numerous numerical experiments carried out, it was observed that the problem is very sensitive to value of the parameter. Small variation of their values may cause a very different behavior of simulation results. Okay, now. The second case study is about the St. Peter monument, and the phenomenon is the sectarian concretion. A great number of historic buildings and monuments are often composed of carbonatic-based stone materials susceptible to deterioration by the action of acidic substance due to, an example, air pollution on its main component, that is the calcite. However, the mechanism of degradation on the stone and the factors that affect them cannot be simply specified due to the sound process involving physical, chemical, and biological changes associated with capillarity and porosity. Because of the management of a large number of samples and the cost of characterization analysis, modeling can be a useful tool for the care and protection of real estate over time. The reason why I would like to share with you the particularity of some degradation phenomena also present in nature, as just in with the Liesegang rings, that could be explained through mathematical models that aim to describe how the deterioration of the surfaces of these structures vary over time as a function of the determinants variables considered in different cases. Here I show you a degradation form encountered on the basement of St. Peter's statue in Vatican Garden. It is a chemical physical degradation represented by a dense network of fissures or cracking from which emerge carbonatic compression, but which could also contain lead and copper salt transported by water. At a glance, the morphology seemed to recall the crackle, or network of small cracks, also described by the ICOMOS glossary of degradation forms. The origin of cracking can be different, such as weathering, defect in the stone, static problem, iron rusted insert, too hard fill mortars, or even vibration caused by earthquakes. Okay, in geological field, the degradation morphology closest to our is represented by the sectarian concretion. These are nodules characterized by cracks filled of calcite that indicate a contraction of the inner material, probably occurred during the degradation phase. Cracks vary widely in shapes and configuration and may include extensive network of shrinkage, cracks, lenticular, vertical, or radial, and sometimes concentrically oriented. Many concretions exhibit multiple cracking events. The process that creates and characterizes sectarian concretion remains unclear to date. Various mechanisms have been proposed, including the degradation of clay-rich, gel-rich, organic matter core, shrinkage of the center of the concretion, but all this future evidence that cracking involves inner core responses. Precious solution, cementation with dissolution and precipitation, freeze cycles, and microcracking are other contributions to phenomenon formation. The third case study is a Neolithic boat, the Pirog of Anguillara Sabbatia. It's 8,000-year-old Pirog from the Neolithic village of Marmotta in Anguillara Sabbatia, now submerged by the waters of the Lake Bracciano. Here, the degradation has caused the high loss of woody substance, replaced by high content of water, which compromise its physical and chemical property. The diagnostic investigation for the characterization of its conservation state highlight the presence of ferrous material coming from the environment of preservation. In particular, iron reduced sulfur compound such as pyrite and pyrrhotite. Small crystals are observed both alone and organized in spherical formation called rhomboids. It is important to highlight that such morphology was never documented in any study regarding the iron contamination archaeological wood. The occurrence of both rhomboidal pyrite and a weathered crystal reflect two distinct pathways of pyrite formation. Pyrite formed by bacterially mediated production of sulfide exhibit a rhomboidal morphology. Rhomboidal pyrite is the result of early diagenetic reaction involving a bacterial sulfate reduction associated with rapid iron reduction. During sulfate reduction process, bacteria use the oxygen of freshwater of seawater sulfate to metabolize organic matter, resulting in the formation of carbonic acid and hydrogen sulfide ion. The dissolved sulfide react with iron-bearing minerals to form a stable monosulfide together with elementary sulfur. Rhomboids are characteristic of pyrite. Here you can see some images taken from different studies. Are backscheduled scanning electron microscopy image and reflected light photo micrograph that's showing rhomboids with different shapes. Let's see what happened to the waterlogged wood now. If I have to consolidate the wood matrix, generally with polyethylene glycol, for a correct conservation intervention, I need to remove the iron present in the wood with the use of chelating agent. Here I had the opportunity to conduct an extraction test for iron chelation with set immersion time. The results visible in the image show how the concentration of pyrite granules, almost absent in the sample at time 0, untreated wood, increased over the days until it occupied on the 10th day about 50% of the analyzed surface. The calculation of the minimum dimension of the crystal and of the rhomboidal structure show that the values are in line with the literature data. The dimension of the pyrite rhomboid vary from 4.6 microns on the 2 days of immersion to 21 on the 8th day to remain stable on the 10th day. Microcrystal, on the other hand, are somewhat uniform, varying between 1.2 and 1.5 micrometer. Okay. The exception is the untreated sample with a limited number of crystalline elements, but larger in size. This suggests that increase in the number and size of rhomboid in sample treated with the chelator is related to the neoformation of pyrite microcrystal induced by the presence of the ADTA. We have seen how some software can help in restoration activity and how mathematical models are in recent decades taking space in the field of cultural heritage, but much more needs to be done. A demonstration is given by forms of degradation still little recognized, see the growth of the framboids in wood. A mathematical approach opens a myriad of possibility for analysis and processing of the problem encountered, useful for a better understanding how to intervene to protect and prevent the degradation of our cultural heritage. Thank at all.
Thank you. We have time just for a very quick question. Do you have any? Please.
It's possible to prevent this degradation, particular degradation pathologies. Leasing up that are next. Maybe it is better to maintain the design of the type. Or
yeah, it is possible to prevent if.
No, finally, it is possible to remove. No.
Yeah. Not sempre, not even.
Not always.
Not always. Not always.
First, second, is it possible to prevent the process? And what do you think? In some cases, it is better to maintain is as a sign of a passing of time.
Yeah, it's possible to prevent making a substitution of iron, linchpin, or other material in metallic compound. But if I can do this, I can use a protective layer.
Yes.
On the metal. And in some cases, regarding the cleaning aspect, I can remove the oxidation when the stain is very on the surface, but not when it's inside, so much inside, because there is a chemical damage. There is an interaction about the iron oxide and the carbonatic material, and there is a destruction of the crystalline structure, where the ion of the iron substitute the ion of calcite. Okay. And if I remove, I can leave at all.
Yes, yes.
Okay. Okay, thank you. Any questions? Other questions? If not, we thank again Rita and all the speakers for the morning. Participants who are online, and we convene here at 2:30. Yeah.
Just an aspect. If some of you need a certificate of participation, please let me know, and then I will send you by email.